23. If you have a different color pen, I'm going to use a red one just to make you see a pattern when I give you the formulas. So give me 1 second. So cosine law. I'm just going to tell you this. Recall, and remember, I'm not too worried about you remembering these, right? But if you have any of these cases, they all have a pair. Like if you have these cases, you'll be able to somehow get a pair out of them. You will be able to use sine law. But that's going to change. Okay, sorry. So the two cases, here I don't mind using the letters. I do not mind it. So if it's side, 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 right, you know all three sides. You can do this. There you go. Side, side, side. There's a check mark on all of them. So that's just an oblique triangle. This one is definitely an obtuse, but still, if you know all three sides, there's no pair, right? There's no way to get a pair because you don't know a single angle. So either remember side, 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 or just remember that there's no pair. The other one is called SAS, and I want you to focus on the fact that the angle is in between the two sides. So let's say you know this angle right here, and the sides, it's kind of sandwiched in between the two sides that are known to you. Let's go over here. Let's say you knew this side, and the angle in between. That would also be an SAS. So in these two cases, and you're like, why are you giving us 4 triangles? Well, I'm just giving you the oblique, which could be an acute. This is also an oblique, but it's definitely an obtuse triangle. So I'm just telling you, it doesn't matter. It will work, but if you notice that pattern, no pair, okay? In these cases, right, you do not have a pair. I'm highlighting that there. Which means, right, we need to use cosine law. No pair, use cosine law. Okay. So here we go. Here are the formulas. I'm going to give you 3 variations, but you only need to remember one of them. So if it's the SAS case, 2 sides with the angle sandwiched between, right? So let's say we know these 2 sides here. This side, that angle there. Then the formula is going to look as follows. Listen carefully. There's something with both laws where you need to know the angle across the side you're trying to find. Okay? You know this angle, right? So you'll be able to solve for this side right here. In this particular case, that is it. So we're going to say our formula would have to start like this. X squared. I'm using red for that one. That is going to be equal to c squared. You take one of the known sides, you add the other known side, then you go minus 2 times that first side you grabbed times the second side times cosine, and here I'm using my red pen again, cosine of that angle across the side you're trying to find. Nice capital there. Okay. I want you to focus on the pattern. Watch this. You wanted side x, so I had to use angle x across here. By the way, that's the only angle that will be provided to you, right? C and y in this case are also known, so these are just numbers. You just plug them in and you go. And at first it looks like Pythagorean theorem, but it's not Pythagorean theorem. Okay, so let's say, for instance, you wanted to solve for y. So you had like an SAS up here. Okay, then you would write it out like this: y squared if you want y squared, that means that you know, careful here, right? That means that you would know c and x. So we go c squared plus x squared minus 2 times c, right? Because that's the first one I put down here, times x times cosine of angle y. So this would allow us to solve for x, this would allow us to solve for y, and we still have to solve for side c. So we're going to go c squared would be, if c squared is what you want to find, that means that x and y would be provided. So we would go x squared plus y squared minus 2 times x times y times cosine of angle C. So these are the three variations. You only need one. So this is what I'm going to do here. And if you want to add to your study sheet, right? Because really you just need to see the pattern, right? How would that work? I just rewrote it in 3 different ways, depending on the scenario, right? And as we do examples, you're gonna get the gist of it. Okay. So here we go. This would be when you have an SAS scenario, you use this formula. Now watch, go with me to page 24. SSS case. Okay. If you have side, 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 the only thing left to do would be to start solving for angles. So you know this side, and this side. Those, instead of letters there, you would actually have numbers, right? You'd actually have numbers show up there. So let's say you wanted to solve for this angle x here. Then you would start your formula like this. First of all, you realize it's cosine law, so you'd have to go cosine of that angle, angle x, right, would be equal to, draw a long line like this. There's going to be some stuff in the numerator. We're going to have some stuff in the denominator. The first thing that I want you to write down is the side that's across angle x would be side x, and that would be minus x squared at the end like that. And what comes in here, right, are the other two sides. So c squared plus y squared, like that. And in the denominator, you'd have 2 times c times y. 2cy. This is basically just, remember the first 3 that I gave you? They're just rewritten. We rewrite it so that, let me just show you real quick. We rewrite this one. Right? I just rewrote this one so that this is isolated, right? So that's why it looks similar, but totally different, really, in terms of where the numbers go. Okay. So that's version number 1. Let's say you wanted to solve for angle C right here. then you would go cosine of angle C. That's the angle you're trying to solve. You go line like that. You're like, okay, I'm trying to solve for this angle here. I need to grab the number that's across from it, square it, and make sure that a minus goes in front. You subtract. That's very important. So if you've used C, you use the other two sides here, which is x squared and y squared. Okay? And then these two numbers show up again in the denominator like this, right? XY show up again here. That's the pattern. Let's do one more. Cosine of angle Y. You go line like this. Make sure you go minus y squared. That means that c squared and x squared are the other two numbers. Order does not matter here. You could go x squared, then c squared, it doesn't matter. 2 times c times x. Okay. So the variations are just for you to see the pattern. But again, if you make your study sheet, okay, you're gonna just box this one in here. You're gonna say, for an SSS case, I need this formula. SAS, I need the other formula. Okay. How's this different than sine law? Sine law is the same every single time. You set it up the same way at the beginning. You don't need to choose between two formulas, right? With cosine law, you need to choose between two formulas. Okay. So you gotta watch out for that. Watch what I'm going to tell you here on the side. This is very important, right? Because you have a minus squared at the end here, there's a chance that you have a negative numerator. And what that means is that the angle will be obtuse. Cosine law actually knows the difference between acute and obtuse. When solving an SSS triangle, you start with the largest angle. More about this later. Okay. Can I just add a note here on the side? Cosine distinguishes between acute and obtuse. And this is what really happens in the background. So imagine you have two angles side by side. Cosine, if it notices that your numerator is negative, it's going to give you this angle right here. If your numerator is positive, it's going to give you this angle right here. Right, this is acute, obtuse. And if this doesn't make sense to you right now, don't worry about it. I'm just giving you a little heads up for later. Okay. So cosine knows the difference between obtuse and acute. Sine law doesn't. And that's a problem for us later, way down the road. So let's solve a few. Let's put this into practice and actually apply these laws. Right? So come with me to page 25. Okay, so SAS examples, I'm going to start with that. So it's asking us here to solve for side P. Then solve for angles R and angles Q. Calculate the height of the triangle. Not yet. We're going to pause on that for a bit. Watch on the side here. you need to determine which law you will use to start. Only one of them can be used at the beginning. So in this case, you notice, right? You should notice this side angle side, side angle side, right? This is an SAS cosine law. You can also say, hey, I can't find a pair. That's another way of remembering. I can't use sine law, so it must be cosine law. Okay. So if you want to solve for side P, you need to use the formula for SAS, which calls for P squared is equal to, what are the other two sides? Q and R, right? Q squared plus R squared minus 2 times Q times R times cosine of that side that I'm trying to find. That's your pattern. So we're doing, let's make sure we tell ourselves we're solving for question A here. So it's actually not that bad. You don't need to write out the formula every time. But P squared pencil is caving in on me. Here you go. Let's try this one. Q is this side right here. Let's put Q there, and R would be over here. Okay. Q and R. So Q squared plus R squared minus 2 times Q times R times cosine of angle P. And watch this. The next line, you can do this in 3 lines. Okay. P will be the square root of whatever this gives me. And because we have awesome calculators, we can type this in one shot. One shot. So I'll show you. Clear my screen. 8 squared, which you know is 64, right? Plus 5 squared. I just press the x2 button. Minus 2 times 8 times 5 times cosine of 70. Type it all in one shot. And then hit enter. And this is 61,638 ... I'm using all decimals here. And to find P, we just go second x2 to call square root, go up to that number, take the root of that, so you get 7.85. That's how you do it. I will make a note here. Note, you now have a pair. You notice that, right? You actually have a pair now. You could use sine law to solve the triangle. I want you to be aware of that. It's going to happen. Some of you are going to say, I like sine law more. So now that I found my pair, I'm going back to sine law. That's fine. Your answers will be slightly off, but as long as you show me your work, you're fine. Okay. We're going to continue our journey. What does B? B is asking us to solve for angle R and then angle Q, right? we know all sides, which is an SSS, right? Would you agree that we know all the sides of the triangle now? So it turned into a side, side, side as well. So if we want to solve for angle R, we would have to use this formula. Cosine of angle R is equal to, long line like this, you're going to go minus R squared here. And what are the other two sides? If I'm using R here, that means I have to use the other two sides over there. So it's P squared plus Q squared. You don't have to write down the formula down the road, but for now we're doing that, right? And that's 2 times P times Q. I want you to, if you remember the top, the bottom is easy because you just grab these two and put them down here again. So let's plug in. Cosine of R is P squared, which is 7.85, right? We just found that, plus Q, which is 8, square that, minus R squared, divided by 2 times P times Q. Q is 8. And watch what I'm going to ask you to do here. Don't do everything in one shot. We'll do the top and then the bottom separately. So you grab your calculators. 7.85 squared plus 8 squared minus 5 squared. And I want you to use all decimals, right? So you're going to go 100.6225. Okay. And then you go 2 times 7.85. This is the denominator I'm doing now. Times 8. That's 125.6. And then I want you to do one more. I usually don't like trains, but this is actually accurate to say. Right? This is not a proportion. We're just saying this is equal to this, which is not equal to. It better start with a 0. Okay. So we're going to just grab the numbers on our calculator, right? Copy paste top divided by the bottom there. It's 0.801, and that keeps going like that. And this is the final step. Angle R, we're using cosine law, right? We're going to have to use cosine inverse of 0.801 ... like that. So we go second cosine, copy paste, right? Copy paste, enter. So that's 36.76 is my angle there. 36.76 degrees. That's angle R. And angle Q, which is the other one they wanted, it's just 180 minus the 70 minus the 36.76 that I just found. Which is 73.25 degrees. That was just used, I used sum of triangle to figure that one out. Okay. Before we go, right, we're going to try this right away on the next page here, on page 26. let me just see here. Yeah, page 26, give that one a try. Solve the triangle, which means solve for all angles, all side lengths. Okay. Don't worry about determining the height at the bottom of that page. Don't worry about that. You may also use sine law if you prefer. It's up to you. Okay. I would say for today, stick with cosine law so you get used to cosine law first, and then we try that later on, right? The answers to that one. So I'm just making a note here. Since it's SAS, right? Two sides and the angle wedged in between, you know it's cosine law. Angle C is given, right? That's the only angle given. So you have to start with side C. There's no option there. So C squared is 13 squared plus 26.7 squared. That's 2 times 13, 26.7 cosine of 103, right? C is therefore, don't have the original on me here. There's your answer for C. So I'm going to kind of block that off like that. There. And now it's in a side, side, side. So you determine you want to solve X or Y. It's up to you really. If you want to solve for Y first, just remember, right, if this is the angle you're trying to find, put that number at the back, subtracting and squared, right? And then the other two numbers, one of them being the one you just found, right? And the other one is 26.7. Just square and add them in front. And then in the denominator, those two sides show up again. Okay. So you get 1582.0184 and get 1720.548 in the denominator, and that gives you top divided by bottom 0.91, and that keeps going. So angle Y is cosine inverse of 0.91 continued. So angle Y is inverse cosine, and that gives you 23.15 degrees. Okay, I'm off by a little bit. I know why. Because I probably solved it the other way. I started with angle X and then, so you might be off by 0.01, not too worried about that. So angle X is just 180 minus 103 minus 2315. Angle X will be 5385 in this case, if you did it the other way, and that's fine. This one will be later. After tomorrow's lesson, I want you to figure out the height of the triangle, okay? So make sure you highlight that. Don't forget about it, because they will probably assign that, okay? The previous one also asks you for height. So let's go back and highlight that. So let's go to 25, and we'll say later, right? See you later. Okay, so both pages have the height. I don't want you to forget about them, because when I teach you the pages before this, I'll show you how to find the height, and it's actually not too bad. Just find a spot on that page to do so. Okay, I'm going to stop here. Write this down. The homework, if you just want to stick with cosine law, pages 27 to 28 in this workbook, in this book, right? You only have one book now. Thank goodness, right? So there are 3 questions there where you solve the triangles. Do as many as you need to. If you want to practice both laws, pages 31 to 33, there's a key on page 34. So all those triangles that you see there on page 34, they're all completely solved. The only downside is it's rounded to the nearest whole number, not 2 decimals. So you'll have to just go with it. If you want to, add stuff to your study sheet now, maybe do so. And tomorrow we'll figure out the height of a triangle and just move past it, all right? It's very important that you try these. You're comfortable with them. You know the pattern, all that stuff, right?